So today we're going to talk about some really important ideas, and we're also going to talk about irrational numbers and estimation. But let me just remind you of what we already know about square roots. We're going to start out with square roots, and you know that, for example, the square root of 16 is 4, and what that really means is that 4 multiplied by 4 is 16, right? And that's very straightforward. And you also know the square root of 25 is equal to 5. And by that, what you mean is really that the square of 5 is 25. That's what you already know. Okay? But here's a question. Can you really define the square root of a number like 17? Right? Okay, that's a question that you have to mull over. Because what should that mean? Well, I mean, what it should mean is that if there is a number which is the square root of 17 and we want to call it a, then if you look at the earlier examples, then what it should mean is that a multiplied by a should be equal to 17. So is there such a number? Now, a clearly cannot be a whole number because if I take a to be 4, 4 fours are 16, and if I take a to be 5, then 5 fives are 25. So clearly, it's not going to work. But can fractions work? So we're just dealing with whole numbers. So now what about fractions? So let's think about fractions. Okay, and let me just remind you of fractions and especially decimal fractions. So remember that 4.1 really means a fraction which is 41 over 10. And for example, 4.12 really, this is the meaning. So this is really 4.12 is really notation for a fraction which is 412 over 100. Okay, so this is really what it means. So this equality is really notation. Okay, this is not a equality that you calculate, but all these are, this is just notation. So this is just a reminder of what decimal fractions are. So we can try playing with decimal fractions. We've learned in elementary school how to multiply fractions. So let's see what we can do. So let's try. So if I multiply 4.1 with 4.1, turns out to be pretty good. The number that I get is 16.81, and that's pretty good. Okay, it's getting close to 17. Remember, I want to figure out the square root of 17. The question was, what's the square root of 17? So we're trying to find a number a such that a multiplied by a is equal to 17. So we found a to be 4.1, and that's getting close to 17. It's 16.81. Let's go on. Let's try a better approximation. Let's try 4.12 multiplied by 4.12. Turns out this is equal to 16.9744. Oh, we're getting quite close. We are actually within 3% of the right answer because 16.97 is just not even just 3%, even better. We are in fact between less than 300ths of the right answer. Okay, so let's try more. Let's look at 4.123. That's even better. So if I look at 4.123, which is another decimal fraction, we find out that this is actually equal to 16.999129. Okay? And if we go on, we'll find that the number, we can find better and better approximations to a such that a times a is getting closer and closer to 70. So maybe, and that's the thing, that maybe we can define the square root of 17 to be a number which seems to go on forever. I can actually find a better approximation, and we can continue going to the next decimal place and the next decimal place and the next decimal place. So this actually just goes on forever, dot, dot, dot. So you can find better and better approximations to the square root of 17, because when I multiply 4.12310 blah blah blah, it continues to go on, it gets to be closer and closer to 17. Okay, now these guys are actually called irrational numbers. So this number, the square root of 17, is a new kind of number. You haven't seen it before. These are called irrational numbers. Okay. Now, irrational numbers are numbers that we'll get to talk a bit more about later on. But in general, in school mathematics, we don't really consider irrational numbers very carefully because they're really hard. It's only in the 20th century, which is just about 100 years ago, that we sort of understood what irrational numbers mean. And there's a lot of mystery shrouded with these irrational numbers. But right now, at least I hope that you can sort of see that this kind of number, which is the square root of 17, we can start to begin to define a number which is called the square root of 17. It seems to be a number that is like a decimal fraction which goes on forever. There are some properties of this decimal number that we're not going to talk about, but this is what I wanted to talk about. That every number seems to have a square root. Now, the square root may not be a whole number, it may be an irrational number or a fraction. So that's what I want you to take away from this discussion. So now, what we can do is that we can do crude estimates. So now we can estimate. So now that we know that this number exists, because we first weren't sure that this number exists, now we can estimate. So if somebody asks you what's the square root of 17 approximately, you can say, yeah, approximately. So this is just a symbol of approximately. This is a symbol for an approximation. So this is just saying approximately is 4. And if somebody were to ask you what's the square root of 24, remember 24 is 25 is 5 fives, so maybe you can say the square root of 24 is approximately 5. Now, if somebody were to ask you what's the square root of 20, now that's somewhere in between 17 and 24, so maybe you can just approximate and say this is 4.5. I'm just giving you crude ideas of how you can approximate. Similarly, if somebody asks you for the cube root of 63, now you know the cube root of 64 is 4, so maybe you can say the cube root of 63 is also 4. It would also turn out to be true that the cube root of 65 is also 4, approximately. And clearly, this would actually be, the cube root of 63 would be less than 4, and the cube root of 65 would be more than 4, because 63 is less than 64 and 65 is more than 64. Okay, and similarly you can think about it. What should the cube root of 30 be? Well, the cube root of 30 is going to be close to the cube root of 27, which is 3, so you can approximate it as 3, but it's going to be slightly larger than 3. And you know the cube root of 64 is 4, so if somebody were to ask you what's the cube root of 50, you can approximate it as maybe 3.5. Okay, so these are just crude estimates of what you can do when you're trying to estimate these numbers. So maybe I should point out that this is somewhere, because it's between 63 and 30, so that's why you're sort of saying the cube root is between 3 and 4, which is 3.5, just as you looked at this and this, and you saw that 20 was between 17 and 24, so the square root of 20 was between what the square root of 17 and 24 would be, which would be approximately 4.5. So I would suggest, as usual, go ahead and do some practice on your own, so that you can learn how to approximate these square roots and cube roots. Thank you.